Okay, this picture over here is from a Desmos graph that actually does Riemann sum calculations. We're trying to find the area under the curve from of the function 2 cosecant of x from pi over 2 to 3 pi over 4. And there's the 4 brown or tan rectangles with the little green area above 2 cosecant of x, which is this curve. So the area is an overestimate. Here's the actual area, the approximate area, sum of the areas of those 4 rectangles. This is the actual area under that function. So the green portion of that picture is the overestimate. So how do you do this by hand? Well, the left-hand endpoint is pi over 2. The right-hand endpoint is 3 pi over 4. The number of rectangles is 4. So delta x, which is the width of each of these rectangles, is b minus a all over 4. And if I want to simplify that complex fraction, there's a couple ways to do it. I just picture multiplying top and bottom by 4, which clears the complex fractions. And we get pi over 16. So that's the width of each of these little rectangles down here, pi over 16. Now we're supposed to use right-hand endpoints, right-hand Riemann sum. So that means we start at A and add on 1 width to get to the right-hand endpoint. So that's what this is, x sub 1. Start at the left-hand endpoint, which is pi over 2, add on 1 width, and that's our first x sub 1 right there, 9 pi over 16. And you could go through x sub 2 is pi over 2 plus 2 widths, or you could say I'm just going to add pi over 16 to the previous x sub I to get the next x sub I. And now you plug each of those values into the function. That's what's happening right here. So in red, this is the height of the first rectangle. And then I have to multiply that by pi over 16. So this distance right here is 2 cosecant of 9 pi over 16. And length times width gives you the area of this first rectangle. I can see that 2 times this width is going to reduce to pi over 8 every time. And so there's formulas, or there's the values for each of the areas. Add those together and you've got the estimate. I notice that every one of these areas has a pi over 8 in it. So I can factor that out and just take the cosecant of each of these x sub i's. And that's what these values are right here, the function value at each of the x sub i's. If you add those all together and then multiply by pi over 8, you'll have this approximate area right in here, which is what this is. Okay, there you go. Have that help. I'm going to include a link to the Desmos graph that does Riemann sums in the video answer.